Hi guys, welcome to ACT Science Test. It is set 6, question 1 to 22. We're almost done, so try to time your limit and solve questions. Okay, so let's get started. Passage 1. So in passage 1, this delta T is very important. T final minus T initial. T is temperature. So when a substance dissolves in water, heat is either absorbed from or given off to the solution. So we are going to use two substances, LiCl and NH4NO3. We are using no mass of everything, so no mass of solute, water, and known initial temperature. And we are going to measure TF, and if TF is higher than T initial, you'll see positive delta T. If TI is bigger than TF, so this is bigger, then you will see negative delta T. Okay, let's move on to the next slide. So here you see two figures, figure 1 and 2. In figure 1, you use the mass of LiCl. In figure 2, you use the mass of NH4NO3. As you increase the mass of LiCl, you increase the delta T. And here, delta T is positive. That means, delta T is TF minus T initial. If it's positive, that means TF is higher than T initial. So T final is higher than T initial. That means you added heat to the solution. Added heat. So you added heat to the solution later, so delta T is positive. Here, delta T is negative. As you increase the mass of NH4NO3, you decrease the temperature of the final. That's why delta T is negative, because this one is TF is lower than T initial. That's why you have minus. So you have to know the difference between figure 1 and 2. Okay, let's move on to the next slide. Question 1. Based on figure 1, when 15 grams of LiCl was added to 75 grams of water, the temperature. So here they're asking you about the temperature. Okay, let's move on to figure 1. So here's figure 1. They said 15 grams of LiCl in 75 grams of water. Here, when you see the temperature increase as you increase the mass of LiCl. So you have to say temperature increased because heat was removed from the solution, because heat was added to the solution. If you said removed from the solution, that means you didn't add the temperature, you subtract the temperature. So here, temperature initial has to be bigger than temperature of final. Added means you add the heat. Temperature of final is bigger than temperature of initial, so the answer has to be D. Question number 2. Consider the trials represented in figure 2 involving 20 grams of NH4NO3. From trial to trial, as the concentration increased, what happens to delta T? Okay, let's look at figure 2. So here, figure 2, NH4NO3. The question said 20 grams of NH4NO3. So 20 grams here. As you increase the concentration of NH4NO3, you see decrease in delta T. So delta T decreased only, so the answer is H. Question number 3. If additional trial had been done in which 23 grams of LiCl had been added to 50 grams of water, what happens to delta T? Or what is delta T? Okay, let's move on to the next page. Here, everything ended in 20 grams of LiCl, so from 0 to 20. Let's say we had additional trial and we added 23 grams. So 21 here, 2, 3, 23. And 50 gram of water. So 50 is here, 23 is here. Let's go up, way up to 50. So let's say here delta T is increasing. So the delta T will be higher than 40. So greater than 40, the answer is D. Question number 4. According to figure 2, so you have to see figure 2, when 12 grams of NH4NO3 was added to 100 grams of water, the temperature, so once again, it's asking you about the temperature. Let's go back to figure 2. So here's figure 2, and they said 12 gram. So 12 gram is here, 10, 11, 12, in 100 gram of water. So if you go to that, it's around here. What happens to the temperature? Temperature decreased. So it's keep decreasing. If you see from 0 to 12, so temperature decreased because delta T is what? Negative. So you have to say decreased because delta T was negative. So the answer is G. So here delta T is very important because delta T is equal to T final minus T initial. You see that delta T was negative. That means T initial is higher than T final. Okay, let's say T initial was 25 Celsius and T final it's like 22 Celsius. So total is -3 Celsius. So you can say temperature decreased from 25 Celsius to 22 Celsius by looking at delta T. So that's why decrease is the right answer. Okay, let's move on to question 5. Question number 5. Based on figures 1 and 2, which of the following combinations of the solute and water at a known Ti or T initial would produce the greatest decrease? So greatest decrease in temperature. Okay, let's look at figure 1 and 2. So here's figure 1 and 2, and they said greatest decrease. If you see figure 1, this is increasing. The delta T is increasing. That means T final is bigger than T initial. Temperature increased. So figure 1 is not the answer. LICL should not be the answer. Here, figure 2, delta T is negative. That means T initial is higher than T final. So greatest decreased. We have same gram of NH4NO3, but added to where? What gram of water? Here, the 50 grams of water has the greatest decrease compared to 75 and 100. So you have to choose low gram of water. So now you have 5 gram of water, 15 gram of water. You have to choose the low gram of water. So the answer is C. Okay, let's move on to passage 2. So passage 2, you will see machine called SEC, and SEC looks like that. And it is used to separate the components of a solution of polymer molecules. And this machine contains beads, and these beads have pores. Okay, let's move on to the next page. So here says smaller molecules easily diffuse into the pores. So what it means is that you have column and beads are there. You will see pores in the beads. Let's say solution contains small, medium, and large molecules. Small molecule is small enough to diffuse into the pores. So pore number 1, number 2, number 3, number 4, and then exit the column. So it would take more time to exit the column because it would diffuse easily compared to medium and large. But large one is too large to get into the pores, so it would just exit right away. That's why you use SEC to separate the molecules. So here, a component of the mixture exits the column through the detector, and you will see the peak. So the big one comes out first, so you will see the big one, big molecules first, and then medium, and then small. This RT corresponds to the average molecular mass, so AMM mass. So I'll show you the peak later on. Okay, let's move on to the next page. So here in experiment 1, you see table 1. And this table 1, 1, 2, 3, 4, 5, they're differ by the size or the mass. So if you have a bigger size, bigger mass, smaller size, smaller mass. P1 is the smallest and P5 is the largest. So the lightest, the heaviest. Okay, let's move on to experiment 2. So here you see a sample of solution was injected into on SEC and you see peak. So here RT minute, so time. P5 took the shortest time to exit the column. That means this one is the largest or the biggest. And if you see P1, it took a long time to exit the column. That means it's very small and it diffused into pores easily. That's why it took such a long time to exit the column. All right, so if you look at the size, this one was the biggest, has the heaviest mass, and this one had the lightest mass. Okay, let's move on to the next page. So in experiment 2, chemists used 3 different methods to synthesize polystyrenes, forming the mixtures M1, M2, and M3. Okay, let's move on to the next page. Question number 6. In experiment 1, the molecules of which of the following polymers spend the shortest amount of time? Shortest time. Okay, let's look at experiment 1. So which one spent the shortest amount of time in the column? That means which one came out the fastest. Here P5 has the highest mass, so really big one, large one. And this one, P1 has the smallest mass, so small molecule. In the column, they have beads, and small one, they diffuse into the pores, so it takes a long time to exit the column. But the big one, it doesn't diffuse into the pores, so it just comes straight down and exit the column. So the big one will take the shortest amount of time to come out from the column. So P5 is the answer, so the answer is J. Question number 7 of experiments 1, 2. M3 is most likely which polymer from experiment 1? Okay, let's look at experiments 1 and 2. So here this graph is from experiment 1 and the bottom one is from experiment 2. If you look at the peak from M3, this one has the same peak here and over there. So that means M3 is a mixture of P3 and P1. So P1, P3, the answer is B. Question number 8. In experiment 1, on average, did P5 molecules or P4 molecules more easily diffuse into the pores of the beads while in the column of the SEC? Okay, let's move on to experiment 1. So the question says easily diffuse into the pores. So if you could easily diffuse into the pore, that means that molecule is small. So small enough to diffuse into the beads. So which one is it, P5 or P4? P5, it exits the column around like close to 5 minutes. And P4, it exits the column around like 5.5. That means this one took less time to exit the column. It was a little bit bigger than P4. So which one was more easily diffused? This one, P4. It was a little bit smaller than P5 that it diffused into the pore a little bit more easily, and it took more time to exit the column. So you have to say P4 because they have larger or smaller. You have to say smaller. So the answer is G. Question number 9. Based on the results of experiments 1 and 2, which of the following ranks P3, P2, and M1 from largest AMM to smallest AMM? So AMM is mass. Okay, let's go back to experiment 1 and 2. So here you see P3, P2, M1. Here M1 around 3, around 7.5 for P3, and 10 for P2. So it took the shortest time for M1 to come out, and it took the longest time for P2 to come out. So which one is the largest? This one is the largest because large one cannot diffuse into the pores. It just comes down to the column, exit the fastest. So this one is the largest one. P2 is the smallest one because it took the longest time for P2 to exit the column. So from largest to smallest, M1 is the largest and P2 is the smallest. So the answer is D. Question number 10. How does the number of molecules in a 1 gram sample of P5 compare to the number of molecules in a 1 gram sample of P3? So you're comparing these two. Okay, let's move on to the next slide. So here P5, the mass is 200,000. P3, the mass is 10,000. So if this one has a greater mass than that, that means this one is larger. So in 1 gram, P5 is larger than P3, so smaller, P3. P5, P3. So if this one is larger and has a greater mass, that means you have less molecules compared to P3. Since P3 is smaller than P5, it can have more molecules inside or in the same gram, in 1 gram. So you have to say the number of P5 molecule is less because P5 has a larger mass than P3. So the answer is F. Question 11. In which, if any, of the mixtures synthesized for experiment 2 is the average mass of the molecules in the mixture most likely greater than 250,000? Okay, let's go back to experiment 2. Here the question said greater than 250,000. So if you look at P5, it's 200,000. So 250,000 is bigger, greater than 200. So it has to be around here. The 250,000 will come out faster than P5. So is it M1, M2, or M3? It should be M1 because M1, it came out around 3 minutes. It has to be faster than 4.8. So the answer is M1. A is the answer.